Dear students, now today topic is complex number objective. Until yesterday class, we have completed De Moivre's theorem IP successfully. Complex number and De Moivre theorem, two topics are same, treated as objective concept. So let us going to discuss today synopsis. This is a lengthy topic and most IMP topic in objective concept, of course in advanced also. So let us going to discuss synopsis. Maybe the synopsis takes 3 or 4 classes. Let us put side heading integral powers of iota. Integral powers of iota. If z is equal to x plus iy is a complex number, where I square is equal to -1 comma I is equal to root of -1. I square equal to -1 comma I is equal to root of -1. Here I is called as iota. It is a Latin word. The iota means here we are indicating imaginary. That is equal to x plus I is a complex number where x is the important, I is imaginary part. The special letter of the imaginary I is iota here. So I is equal to, so the iota value I is equal to root of -1 and I square is equal to, I is equal to root of -1, I square is equal to -1. Now powers of iota. Let us try to understand. I cube is equal to I square into I, so it is -I. So I power 4 is equal to I power 4 is equal to I square whole square. It is -1 whole square. It is 1. Now let us discuss I power 4 according to our objective material, page number 3. I power 4n I am writing. I power 4n you can write as I power 4 whole power n. Of course it is 1 power n, that is equal to 1. Now I power 4n plus 1 can be written as I power 4n into I. So that is equal to 1 into I, that is equal to I. In the similar way, now you can understand these are fundamental concepts. I power 4n plus 2 is equal to I power 4n into I square. So 1 into I square is -1. So I power 4n plus 2. If they given as I power 4n plus 2, I power 5n plus 3, I power 9n plus 9, I power n whole power n like that, then simply you can understand putting n is equal to 1. By the natural number concept, you can do all the sums using shortcuts. Now I power 4n plus 3, of course you can understand now I power 4n plus 3 becomes I power 4n plus I cube. So I cube is equal to -5, directly you can write. Now let us consider the example, worked example he given. Find example given as find sigma I is equal to, not I, sigma n is equal to 1 to 200. Sigma n is equal to 1 to 200 I power n. Sigma n is equal to 1 to 200 I power n. So here it is I plus I square plus I cube plus, like this. Put instead of n is equal to 1, 2, 3, so on. I power 1 plus I power 2, like this. I power 3, like this, so on until I power 200. So I you take comma. I have taken comma. You can write here 1 plus I square plus so on. This is iota summation of n natural summation of n numbers for iota. So here you can understand Sn is equal to, try to understand this is a plus ar square plus so on ar power n minus 1. That Sn formula a into 1 minus r power n by 1 minus r. A into 1 minus r power n by 1 minus r, because r less than 1. If it is r greater than 1 minus r power n minus 1 by r minus 1. Because we are calculating the nth roots of unity concept, so I is equal to less than minus 1, root of minus 1. That is why you can write here 1 minus r power n concept. So S 200, so that is summation of 200. You can write I into 1 minus I whole power here until 199 is there. So now you can write here I power 200 whole by 1 minus I. Denominator not equal to 0, students, because I not equal to 1. So you can understand now 1 minus I square I power 200 can be written as I square whole power 100. 1 minus I square whole power 100 whole by, this is I into 1 minus I square whole power 200 by, this is 1 minus I. So I into 1 minus I square meaning is minus 1. Minus 1 whole power 100 means 1. So 1 minus 1 becomes, it is 0. 0 by 1 minus I. So I into 0 meaning is 0. Now the answer is 0. Depends upon, just simply we have said now the properties of iota, integral powers of iota we have discussed. Depends upon this concept you can do integral powers of iota in level 1 or theory bits. Now today let us going to discuss about the properties of complex numbers or properties of modulus also. Let us going to discuss about the multiplicative inverse. Multiplicative inverse. Multiplicative inverse. If z is equal to x plus I by is any complex number. If z is equal to x plus I by is any complex number, then z is equal to x plus I by is any complex number, then z bar is equal to, not z bar. Okay, let us write z bar is equal to 1 minus xy, not z bar. It is called as 1 by z. 1 by z is equal to 1 by x plus I by. So you can write this one as x minus I by x square plus y square. This one you can understand z bar by mod z. So this is multiplicative inverse. So you can write multiplicative inverse of mi. Multiplicative inverse of z is equal to z bar by modulus of z square. Modulus of z square. This is modulus of z square. Multiplicative inverse of z, not is equal to, you should not write it. Modulus of z is right. Also, you remember the formula z bar is equal to modulus of z square. Z bar means z is equal to x plus I by, z bar is equal to x minus I by, x plus I by into x minus I by becomes x square plus y square. Mod z meaning root of component square plus component square. So whole root whole square becomes x square plus y square. So z bar you need to understand as modulus of z square. Depends upon this z bar. Now we can write properties of complex numbers. Properties of complex numbers. Properties of complex numbers. First one, z bar whole bar is equal to z. You can understand this one. Let z is equal to x plus I. Z bar is equal to x minus I. Z bar of z bar is equal to again x plus I. So it becomes z bar of z bar is equal to z. We can understand this one. Negation of negation p is equal to b in the statements and sets. Negation means opposite. Opposite means original. In the similar way, conjugate becomes original complex. So now second one, Z plus Z bar. Let us try to understand everything. Z plus Z bar becomes, Z means x plus iy. Z bar meaning x minus iy. This one get cancelled. This is 2x. This can be understood as 2 real Z. 2 real Z. Real Z means x plus iy. Real of Z plus x plus iy is only x. So 2x becomes 2 real. In the similar way, you can write Z minus Z bar or Z bar minus Z. Z minus Z bar you write as x plus iy minus of x plus iy. X minus iy. It becomes x plus iy minus x plus iy. X and x will be getting cancelled. 2iy. So 2iy, you can understand. This is the 2 imaginary Z. 2 imaginary Z, because imaginary part of the Z becomes iy. Next, Z minus Z bar. If you take Z bar minus Z, it is minus 2 imaginary Z. Comma, you write here Z bar minus Z is equal to minus 2 im. Im means imaginary part of Z. Next, fourth one, write the property Z1 plus Z2 bar. It meaning Z1 plus Z2 whole bar. So what is Z1 plus Z2? Z1 plus Z2, write like this: x1 plus iy1 plus this is x2 plus iy2 whole bar you put. Bar means a conjugate. So x1 plus iy1 plus x2 plus iy2. Take here, write here x1 plus x2. So real part is side plus I taken common and y1 plus y2 taken like this. Put bar here. So whole bar gives x1 plus x2, it's okay. x1 plus x2 minus I of y1 plus y2. So z1 plus z2. Now okay. Now you can understand x1 minus iy1. Right like this. x1 minus iy1 plus x2 minus iy2. x1 minus iy1 plus x2 plus iy2. x2 minus iy2. You can understand this one. This is a z1 bar. Z1 bar plus this is Z2 bar. So what is happening? The property of Z1 plus Z2 whole bar is equal to separate Z1 bar plus Z2 bar. Like that, each and everything we need to verify. Fifth one. So directly I am writing this one Z1 minus Z2 whole bar. You can understand this one as not modulus. You can understand this one as Z1 bar minus Z2 bar. In the similar way, you can understand this one x1 minus x2 like this. You can do using this one x1 plus iy1 minus x2 minus iy2. So x1 plus x2, if x1 minus x2, so x1 minus x2 minus I of y1 minus y2 like that. So z1 bar minus z2. Now next one, z1 z2 into, let us think z1 z2 bar. Fifth one, Z1 Z2 whole bar. Z1 Z2 whole bar. Z1 Z2 means Z1 into Z1. First x1 plus I by 1 into x2 plus I by 2. x1 plus I by 1 into x1 plus x by 2 whole bar. Multiply like this. x1 plus x2 plus I into x1 by 2 plus I have taken common x2 by 1 minus I square. So plus I square becomes minus 1, it is y1 by 2. write like this: x1 x2 minus y1 y2 the bracket plus I taken common. Within the brackets you can write x1 y2 plus x2 y1. Now we need to consider this whole bar. For this one bar, so for this one bar like this. So it becomes x1 x2 minus y1 y2. x1 x2 minus y1 y2 within the bracket minus you put here. For a complex number a plus ib, a minus ib is the complex number. So you don't need to worry about all these terms. Whenever plus symbol is there, simply should change the minus symbol and whatever the number related, the number is a and this number is b. So a minus ib. Like that simply try to understand and write like this: x1 x2 minus y1 y2 minus I of x1 by 2 minus I of x1 by 2 plus x2 by 1. This is the value we got. Now let us verify z1 bar dot z2 bar. Separate. So z1 z2 whole bar can be understood as z1 bar dot z2 bar. So what is z1? Z1 bar x1 minus I by 1 into z2 bar x2 minus I by 2. That is equal to x1 x2 minus I x1 by 2. x1 x2 minus I x1 by 2 minus I x2 by 1 minus of minus plus I square becomes again minus y1. So it is y1 minus y2. You can write now x1 x2 minus y1 by 2. x1 x2 minus y1 by 2 minus we can take common. It becomes x1 y2 plus x2 y1. Now underline this one. Put arrow mark underline. Put arrow mark underline. What did you observe? It is becoming that therefore you can conclude that z1 z2 whole bar. z1 z2 whole bar is equal to z1 bar into z2 bar. Now z1 bar by z2 bar also we can decide. Okay, let us write directly. z1 by z2 whole bar you can write, students. z1 by z2 whole bar is equal to z1 bar by z2 like a property. You take in the similar way the proof. Now let us going to discuss about the another property. Seventh one, z1 is equal to 2 by implication. I think you know already have learned in mathematical reasoning chapter. z1 is equal to z2 by implication, or this meaning if and only if this is okay, whatever the statement now I am going to discuss with you, that is also okay. The statement is z1 bar is equal to z2 bar. Write within the brackets equality of complex numbers. This property is known as equality of complex numbers. So what is equality of complex numbers? Example 1 you take. Of course 1 is a complex number, even though it is real, we can say 1 plus I into 0, it is also a complex number. So 1. Maybe another also 1. So 1 plus I into 0, comma 1 minus I into 0 are both complex number. Then what it becomes? 1 minus I into 0 is equal to 1 plus I into 0. So there is no value for 0 and there is no value for the multiple coefficient of iota, simple iota. So you can understand 1 is equal to 1 in the similar way 1 is equal to 1. So 2 plus I like that, 2 minus I maybe. It is not proper way. Example if you take I, it is also I, 2I, it is also 2I. In the same way you say that equality of complex number meaning is that if two complex numbers are equal, if and only if their conjugates also equal. If two complex numbers and the conjugates of the two complex numbers are also equal, then the two complex numbers are said to be equal complex numbers. Now, page 1. according to modulus. Now I am discussing. Modulus of z is equal to, what is modulus of z? X square plus y square over root. Now modulus of minus z is equal to modulus of z bar is equal to modulus of minus z bar. You think any complex number, the value of component square plus component square will not be negative, even though you are taking negative complex number or positive complex number or conjugate complex number or general complex number. So this is the main property. Next, ninth one. This one also. If modulus z is equal to 0, then in the similar way, if and only if z is equal to 0, unless otherwise it is 0, there is no complex number modulus becomes 0. So for the complex number 0, 0 plus I into 0 or 0 minus I into 0 or I into 0 plus 0 or I into 0 minus 0, such complex numbers modulus is always 0. That is why I am indicating here if and only. So z is equal to 0, then modulus z is equal to 0. Now, next one. Modulus of z power n. Modulus of z power n is equal to, you can put like this. Mod z power n. Modulus of z power n, let us think, take any complex number. Let us try to understand, students, that z is equal to 2 plus 3. N is equal to 2. So 2 plus 3i whole square. 2 plus 3i over modulus whole square. What is meant by 2 plus 3i? So it is the modulus 4 plus 9. So 4 plus 9 here, it is 13. Now z mod z power n. So 2 plus 3i whole square whole mod. 2 plus 3i whole square whole modulus. So 2 plus 3i whole square means 4. This is 4 plus, this is 4 minus 9 plus 12i. 4 minus 9 becomes minus 5. Minus 5 plus 12 by modulus, it is, of course it is 13, you know, because root of 5 square plus 12 square. Now you use the formula z mod z power n is equal to mod z whole power n is equal to mod of z power n. Next property 12. Modulus of minus z. Modulus of minus z less than or equal to real mod. Real z bar, comma, imaginary z bar less than or equal to modulus of z. So modulus of z less than minus modulus of z less than or equal to real z bar. Let z is equal to, take any complex number, students. 4 plus 3. What is real? What is imaginary? Real z. Let us write z bar also. Z bar is equal to 4 minus 3i. Mod z is equal to 5. Minus mod z is equal to minus 5. Now real z in z. Imaginary z means 3. Use the property minus 5 less than real z bar. Real z bar means here real z. Real z bar equal to 4. Minus 5 less than 4, it is true. It is a property. Minus mod is less than real z bar, and in z. What is imaginary z? 3 less than modulus of z is always 5. This is a property you should remember. Whatever the properties I am discussing with you, each and every property and each and every sum and each and every concept, whatever we are going to discuss in objective is 100% apart from IPA. In IPA, complex number is much easy. In objective, it is so dead. So each and every concept you can understand. In our material level 3 standard, meaning is that 100% it is advanced range. In our material level 1 is MSET range, level 2 is mains range, level 3 is complete advanced range. So like that much depth is there in our material. So prepare our material properly to get the mains exam. Now 13th one. Modulus of Z1, Z2. Just we set the Z bar like that. So simply you can write modulus of Z1, Z2 is modulus of Z1 into modulus of Z2. You write the property, no problem. Until this property is okay. Modulus of Z1 by Z2 over modulus. Modulus of Z1 by Z2, you write modulus of Z1 by modulus of Z2. Modulus of Z1 by modulus of Z1 by Z2 is equal to modulus of Z1 by modulus of Z2. Now, main from here onwards, proofs are needed, and it is necessary for mains concept. Z1 plus Z2 modulus of Z1 plus Z2 whole square is equal to modulus of Z1 square. Modulus of Z1 square plus modulus of Z2 square. Modulus of Z2 square plus 2 real Z1 Z2 bar. 2 real Z1 Z2 bar. Proof is needed. Let us discuss about the concept. LHS we take. LHS Z1 plus Z2 whole square over modulus. So you can write here x1 plus x2 plus I into y1 plus y2. x1 plus I1 plus x2 into plus x2 x1 plus I1 plus x2 plus I into concept over whole square. We know that the modulus whole square is component square plus component square. So x1 plus x2 whole square plus y1 plus y2 whole square. x1 plus x2 whole square plus y1 plus y2 whole square, keep aside. And expansion is also needed. Expansion is also needed. So write the proper way here: x1 square plus y1 square plus x2 square plus y2 square plus 2 into 2 taken common. You can write here x1 x2 plus y1 y2. x1 x2 plus y1 y2. Now taking RHS. RHS modulus of Z1 square plus modulus of Z2 square. Modulus of Z1 square plus